Assalamualaikum and salam, we are UniKL. So my name is Muhammad Amirul Aiman and I'm accompanied with Siti Afrina Batrisyia, and today we would like to present our ARDUINO project, aircraft instrument system. So today we are doing two flight instrument, which is the RPM, which uses a joystick and servo, and second we have our EGT indicator, which is using the DHT11 temperature sensor with a monitor to indicate the real temperature.
So for our first instrument, I would like to introduce our RPM meter and also joystick to stimulate the control column and also the airspeed of the aircraft. So whenever I push the joystick to the front, the RPM will be increasing, and when I release this joystick, it back to the normal, which is a 0. So I will pass to the Aiman for the next instrument indicator.
So right now I will be using a candle to simulate exhaust temperature as a heat source. Putting it on the DHT11. So as you can see on the monitor, it is slowly rising, as well as the indicator will be increasing slowly but steadily. Okay, so this is the circuit diagram for our full project. Down here we have a breadboard connected with it is the DHT11 and the joystick, which are not available in the software. So right now I'm replacing it with a switch, but all the circuit is connected nicely with the joystick connected to A10, LCD, the SDA and SCL is connected to the analog pin A4 and A5, and also wire connecting the servo to the pin number 9 and 10, and also lastly the DHT11 connected to the pin 2.
Now, we would like to explain a little bit about our coding in Arduino. First of all, we have to include the libraries for the language, which are the servo, DHT and also wire, and liquid crystal for the LCD. Next, we would like to define the pin number 2 for DHT and also its type. We will also add two servos named MyServo and MyServo2 with declaration of LCD dimension. Our next coding is the variables for the time without using delay and the temperature range on the gauge, which were simulated in the range of 30 to 50 degrees Celsius. On the void setup, we initialize the serial monitor and also the joystick. We also declare the servo pin attached to pin number 9 and 10, and lastly, initializing the LCD screen and the backlight.
Our first coding in the void loop is the time control, which are the millis to avoid start if delay is used, and then to read the temperature sensor by using the float. The next coding is the joystick control for the servo number 2 and the mapping. This code means the servo moves toward the target value slowly, either to the positive or to the negative, depending of by the movement of the joystick. So the next is the mapping and constraints in regards to the temperature. So if the temperature increases, the servo also increases. Next is the coding to print the temperature and humidity from the sensor to the LCD. And last but not least, this is the current reading of servo 2 will be transmitted to the servo.
I think this is all from us. Before I end up our presentation, here is the attachment of the circuit diagrams based on our project. Thank you for watching.